The year is 1941. In the blinding, shimmering heat of the North African desert, the British Eighth Army is losing the war. They are not losing because of cowardice. The British Tommy is fighting with ferocious grit. They are not losing because of a lack of tanks. American Lend-Lease grants and Stuarts are beginning to arrive. They are losing because of a tin can. It was officially known as the 4-gallon non-returnable petrol tin. But the soldiers who had to use it, the men who watched their precious fuel vanish into the sand before it could ever reach an engine, called it something else. They called it the flimsy. And it was a disaster. It was a square, tin-plated steel container, soldered together at the seams like a cheap biscuit tin. It was designed for a peacetime economy, where roads were paved and handling was gentle. But in the violent, vibrating, sun-scorched reality of the Libyan desert, the flimsy was a liability. The seams were soldered so poorly that they often split open just from the vibration of a truck driving over washboard sand. If a crate of flimsies was dropped from the back of a lorry, a common occurrence in the haste of combat, half of them would burst on impact. The leakage was catastrophic. It was a hemorrhage of industrial proportions. British logistics officers estimated that between 30 and 50% of all fuel shipped to the front line was lost before it ever reached a tank engine. Imagine that statistic. For every 2 tanker ships that risked U-boat attacks to cross the Mediterranean, one of them was essentially pouring its cargo directly into the dirt. The desert supply routes didn't smell like sand and sagebrush. They smelled like a swimming pool of wasted gasoline. But the flimsy wasn't just wasteful, it was deadly. Trucks carrying these leaking cans became rolling firebombs. A single spark from an exhaust pipe, a tracer round from a Messerschmitt strafing, or even the friction of metal on metal could incinerate a convoy in seconds. Drivers lived in terror of their own cargo. When the cans weren't exploding, they were crippling the Army's strategic reach. General Claude Auchinleck, the British commander, found his offensives grinding to a halt simply because his tanks ran dry. They weren't outfought. They were stranded, their fuel having evaporated into the hot sand miles behind them. Across the dunes, looking through his binoculars, the German commander, Erwin Rommel, the legendary Desert Fox, watched and laughed.
Rommel was winning because his panzers kept moving. He fought a war of speed and maneuver, constantly outflanking the static British positions. And his tanks kept moving because the Germans possessed a piece of secret technology that the Allies did not. It wasn't a jet engine. It wasn't a guided missile. It wasn't a heavy tank. It was a gas can. The German Wehrmacht Einheitskanister was a masterpiece of industrial engineering. It was robust, stackable, ergonomic, and totally leak-proof. It allowed the Germans to refuel their tanks in half the time it took the British, without spilling a drop. It allowed Rommel to stretch his supply lines hundreds of miles further than his opponents. The Allies were losing the logistics war, but the tide would turn not when the Allies invented a better weapon, but when they finally swallowed their pride and decided to steal the enemy's. This is the story of how American industry reverse-engineered a piece of Nazi genius, flooded the desert with millions of copies, and used Rommel's own design to drive him out of Africa. But the question remains, how? How did a simple stamped steel container become the decisive factor in a war of heavy armor? And how did the American logistical machine manage to feed, fuel, and arm 1 million men across an ocean, turning the tide of the entire war through the sheer force of supply? To understand the miracle of the jerry can, we first have to understand the sheer, overwhelming scale of the nightmare that was the North African campaign. When the United States entered the war after Pearl Harbor, the platters in Washington faced a logistical problem that had never existed in human history. They had to transport an entire army, 107,000 men initially for Operation Torch, growing to over 1 million, across the Atlantic Ocean, land them on hostile beaches in Morocco and Algeria, and then sustain them in a desert where there was no food, no water, and no infrastructure. The most terrifying statistic of the invasion was not the number of German machine guns. It was a simple unit of weight: 60 pounds. That was the precise weight of supplies, food, water, ammunition, fuel, and medical gear that every single soldier required on the first day of combat to remain an effective fighting unit. For the initial invasion force alone, the Allies needed to land 6.4 million pounds of material in 24 hours.
And that was just the beginning. To sustain an offensive in the desert, where water was scarce and engines consumed oil at a ferocious rate in the heat, the supply chain had to deliver 7 pounds of supplies per man, per day, every single day. If the supply line broke for 48 hours, the tanks would stop. If it broke for 72 hours, the artillery would go silent. If it broke for a week, the army would starve. Rommel understood this math perfectly. He knew that the desert was like an ocean. You could move anywhere, but you couldn't stay anywhere unless you brought your own island of supplies with you. He attacked supply lines as often as he attacked tanks. The Allied supply chain began in the factories of Detroit and the ports of New York. It stretched 4,000 miles across the Atlantic, a route patrolled by the deadly U-boat wolf packs of the Kriegsmarine. Every ship that left New York was a gamble. The first challenge was simply packing the ships. This was not a commercial shipping operation, it was combat loading. In a normal freighter, you pack the hold efficiently to maximize space, heavy items on the bottom, light on top, filling every corner. But in an invasion, efficiency is suicide. If the ship carrying the tank ammunition is sunk by a U-boat, the ship carrying the tanks is useless. If the medical supplies are buried under crates of winter coats, men die on the beach while stevedores dig through the hold. The U.S. Army Quartermaster Corps developed a system of commodity loading. Every single ship in the Torch convoys had to be a self-contained arsenal. Each vessel carried a balanced slice of the Army's needs. If one ship was torpedoed, the invasion force lost a percentage of everything, not 100% of one vital thing. It was a three-dimensional puzzle of lethal consequences. A single Liberty ship might carry 400 tons of bombs, 300 tons of gasoline, 500 tons of rations, 10 Sherman tanks, and a crate of replacement shoelaces. And it had to be loaded in LIFO order, last in, first out. The items needed on the beach in the first hour, bullets, water, plasma, had to be the last things placed on the deck. When the invasion, Operation Torch, began on November 8, 1942, the chaos at the ports of Casablanca, Oran, and Algiers was absolute. These were not modern container ports with cranes and computers. They were colonial docks designed for exporting wine, cork, and olives. They were suddenly asked to inhale the industrial output of the United States. The ships arrived in waves. The docks were overwhelmed. Crates were piled 20 feet high on the quays. Labels were lost in the confusion. In the first weeks of the campaign, logistics officers were tearing their hair out as vital spare parts for tanks were found buried under mountains of toilet paper or crates of officers' typewriters. But the most critical commodity, the blood of the mechanized army, was fuel, and this is where the flimsy almost lost the war. The British flimsy was a product of a different era. It was cheap to make, yes. It was square, which made it easy to pack in a wooden crate, but it was structurally unsound. The thin tin walls would bulge in the heat. The soldered seams were brittle.
Soldiers hated them with a passion usually reserved for the enemy. They were dangerous to handle. The handles were made of thin wire that would cut into your hands if you carried them too far. They were single-use, meant to be discarded, which created mountains of sharp, rusty metal littering the desert for miles. The only thing the flimsy was good for was making Benghazi burners. Soldiers would take an empty, discarded tin, fill it half full with sand, pour in some gas, and light it. The sand acted like a wick, creating a stove to boil water for tea. It was the only time a British soldier was happy to see a flimsy. The Americans had a different system, but it wasn't much better for rapid warfare. They relied on the 55-gallon steel drum. These were durable. You could drop them off a truck and they wouldn't break. But they were huge. A 55-gallon drum weighs over 400 pounds when full. You can't pick it up. You need a crane, a ramp, or a winch to move it. You can't pass a 55-gallon drum by hand to a tank crew in the middle of a firefight. Refueling a tank from a drum required hand pumps and hoses, a slow process that left the tank vulnerable and stationary for long periods. While the Allies struggled with leaking tins and heavy drums, the Germans were racing across the sand using the Wehrmacht Einheitskanister. Developed in secrecy in 1937 under the direction of the German military and engineer Vinzenz Grunvogel, this can was a revelation in industrial design. It held 20 liters, or roughly 5.3 gallons, a manageable weight for one man. It was made of 2 pieces of stamped steel welded together in the middle, meaning there were no soldered seams to split. But the genius was in the details. Every inch of the can had been thought out for combat. First, the handles. The German can had 3 handles on top. To the uninitiated, this looked odd. Why 3? It was brilliant. A soldier could carry a full can by the center handle, which was balanced perfectly over the center of gravity. Or he could carry 2 empty cans in one hand by grabbing the 2 outer handles. This meant a bucket brigade of men could move empty cans back to a truck with incredible speed. It also allowed 2 men to carry 1 heavy can between them, each holding an outer handle. Second, the spout. It had a wide mouth and a cam lock lid that snapped shut with a lever. No tools were required, no threaded caps to cross-thread or lose in the sand. It opened in a second and sealed perfectly with a rubber gasket. You could knock it over, kick it, or drop it, and it wouldn't leak. Third, the breather tube. This was the masterstroke. Inside the spout, there was a small pipe that ran to the air pocket at the back of the can. This allowed air to enter the can as the fuel poured out. Anyone who's ever tried to pour milk from a jug quickly knows the glug-glug effect where the liquid splashes and surges. The German can didn't glug. It poured in a smooth, continuous, heavy stream. This meant you could empty the can into a tank in half the time without splashing flammable fuel onto the hot engine deck.
Fourth, the shape. It was rectangular with rounded corners, making it easy to stack but resistant to denting. It had an indentation on the side, an X pattern stamped into the metal, which added structural rigidity and allowed the fuel to expand in the heat without bursting the metal. And finally, the buoyancy. The engineers had designed the air pocket so that a full can would float in water. If a supply barge was sunk or if troops were crossing a river, the fuel supplies wouldn't sink to the bottom. The Allied soldiers simply stole them. Whenever a British or American unit captured a German supply column, the first thing they looted wasn't the Luger pistols, the binoculars, or the Iron Cross medals. It was the gas cans. They were prized above gold. The soldiers called them jerry cans, using the slang term for Germans. British commanders actually issued orders that captured jerry cans were to be treated as vital military equipment. Units would fight over them, but there were never enough of them to supply the entire army. The turning point came when the Americans stopped being proud and started being practical. The American Quartermaster Corps, realizing the superiority of the design, swallowed their pride. They took a captured German can, shipped it back to the United States, and reverse-engineered it. They made a few tweaks. They simplified the manufacturing process slightly for American mass production methods. They added a screw cap in some versions for compatibility with existing pumps, but eventually adopted the cam lock as well. Essentially, they copied Rommel's design, bolt for bolt. Then, the American industrial machine turned on. Factories in Detroit and St. Louis that had been stamping car fenders began stamping jerry cans. The Blitz can, as it was officially known in the U.S. Army, began to pour off the assembly lines by the millions. By early 1943, these cans were flooding into North Africa. The impact was immediate and profound. The leakage rate dropped from 30% to near zero. A convoy carrying 10,000 gallons of fuel arrived with 10,000 gallons of fuel.
The speed of refueling increased dramatically. A tank crew could refuel their Sherman in the middle of a battle using a bucket brigade of jerry cans, getting back into the fight in minutes rather than hours. The logistics tail could finally keep up with the combat teeth. But the can was just the vessel. The fuel still had to be moved across the desert. And this brings us to the vehicle that carried the can, the GMC CCKW, known affectionately as the Deuce and a Half. If the jerry can was the blood cell, the deuce was the artery. It was a 2.5-ton, 6x6 tactical truck. General Motors built over 500,000 of them. It was ugly, loud, and uncomfortable, but it was a masterpiece of mass production. It had a 6-cylinder engine that could run on terrible gas, 6-wheel drive that could churn through the soft sand of Tunisia, and a chassis that could be overloaded to double its rated capacity without snapping. In North Africa, the Deuce became the camel of the modern age. Convoys of hundreds of trucks formed a massive express route. They drove in total blackout conditions, guided only by cat-eye slivers of light on their headlights. Drivers would wrap wet towels around their necks to stay awake, battling dust storms that clogged air filters in minutes. Many of these drivers were African-American soldiers. In a segregated military that often denied them combat roles, these men became the spine of the operation. Units like the 666th Quartermaster Truck Battalion drove 20-hour shifts, dodging Luftwaffe strafing runs and navigating minefields. They were the ones who ensured that the jerry cans reached the front. They were the unsung heroes who connected the port to the tank. By May 1943, the endgame in North Africa had arrived. The Axis forces were cornered in Tunisia. They were surrounded by the sea and the Allied armies. But the path to victory had been paved with failure. The Battle of Kasserine Pass in February 1943 had been a tactical humiliation for the inexperienced American troops. Rommel had struck hard, destroying their tanks, overrunning their positions, and forcing a chaotic retreat. It was the first time the U.S. Army fought the Wehrmacht, and they lost badly. But logistically, Kasserine was the turning point that proved the power of the American system. The Americans lost 183 tanks, 104 half-tracks, and 208 artillery pieces at Kasserine. For any other army in the world, for the British, the Russians, or the Germans, these losses would have been catastrophic. It would have taken 6 months to replace that equipment. The division would have been combat ineffective for a year. The American supply chain replaced it in 10 days. When the American units regrouped, they weren't just resupplied, they were upgraded. They received the new M4 Sherman tanks to replace their obsolete Grants and Stewarts. They received new anti-tank guns, and they received millions of gallons of fuel in leak-proof jerry cans. Rommel, watching from the German lines, was horrified. He was a tactical genius, fighting a war of scarcity. Every tank he lost was gone forever. His supply lines across the Mediterranean were being strangled by the Royal Navy and Allied bombers. His tanks were running out of gas. His men were eating captured British rations because they had none of their own. He wrote to his wife, The Americans possess an imagination for technology and organization that we cannot match. He realized he wasn't fighting an army. He was fighting a factory. The Americans were fighting a war of abundance. General George S. Patton and General Omar Bradley unleashed a storm of steel. The American artillery fired ceaselessly, day and night. They didn't have to count their shells. They didn't have to conserve ammunition. The zone of interior back in the USA had produced enough high-explosive shells to turn the Tunisian hills into dust, and the truck drivers of the Supply Corps had delivered them to the breeches of the guns. On May 12, 1943, the Axis forces in North Africa surrendered. Over 230,000 German and Italian soldiers were taken prisoner, a number greater than the surrender at Stalingrad. When the German officers surrendered, they were driven to the rear in American jeeps. As they traveled back through the Allied lines, they didn't stare at the tanks or the guns. They stared at the trucks. They saw mile after mile of GMC trucks parked bumper to bumper, loaded with crates of food, mountains of spare tires, and oceans of fuel in those familiar stamped steel cans. They saw soldiers drinking coffee, smoking fresh cigarettes, and wearing new boots. One captured German major reportedly looked at a depot stacked high with crates of American grapefruit juice and shook his head. He realized then that the propaganda he had been fed was a lie. Germany wasn't fighting a decadent, weak democracy. It was fighting an industrial hydra that could ship fresh fruit juice to a desert war zone. The invasion of North Africa proved that the United States could project power across an ocean. It proved that the tail of the army, the quartermasters, the drivers, the cooks, and the clerks, was just as lethal as the tooth. The jerry can remains one of the most enduring symbols of that victory. After the war, the design didn't disappear. It became the global standard for fuel transport. You can still buy one today at an auto parts store. The three handles, the cam lock lid, the breather tube, the expansion indentation, the design is virtually unchanged from the one Rommel used in 1941. It is considered one of the greatest industrial designs of the 20th century. It is a strange irony of history. The weapon that the Germans designed to conquer the world became the tool the Allies used to save it. The road to Berlin didn't start on Omaha Beach. It started on the docks of Casablanca, where the arsenal of democracy proved it could deliver the goods one leak-proof can at a time. If you enjoyed this deep dive into the hidden machinery of war, hit that subscribe button. Click on this to watch our next video. You don't want to miss it. This is World War II Archives.